Hello, welcome to another episode of Exploring Concepts in Sets. Today, we want to continue and talk about equality of sets. So, we want to talk about the equality of sets where we try to find positive square root of not just simple numbers that we know, but then there are cases where we have uh, you being asked to find a positive square root of some numbers, some compound numbers. So what I mean by compound numbers, I mean like two or more terms, right? And those terms may contain also set. An example is they may ask you to find the positive square root of 3 minus 3 root 5. 3 minus 3 root 5. So they ask you to find the positive square root of this. Remember, when we started this session, we said that we are going to focus on positive numbers because we believe that square root of a number, so we have a square root of 4, the actual answer, negative 2 or 2, the two of them qualify. But for our scope of learning, we are going to focus on the positive answers. So here, we are going to just focus on the positive answers. That's why we are going to 3 minus 3 root 5, they usually ask you to find the positive square root of that. So if I give you a number, like let's say if I give you a number and that number is 16, find the square root of 16. What will you do? Find the positive square root of 16. What will you do first? You try to put symbol here, right? And then say, oh, then it is equal to 4. Find the positive square root of 4. What will you do? You go and put the root sign here and then say it's equal to 2. You are looking at only the positive answers. So the same thing for this something compound like this. They say you should find the positive square root of all this. It's not like every single thing, but all of them. So in order to do that, the very first step is introduce your root sign on all of them. Everything under one umbrella of the square root. I know there's this smaller root here, so that's how it should go. Everything should be put under, just like how you were doing it for square root of 16 and square root of 4. So when you say find the positive square root of a particular thing like this, 3 minus 3 root 5, you need to make sure that first step is to put everything in under one umbrella because you are finding the positive square root of everything. We assume that all that will give you a particular answer. So yes, and this one we are going to equate it to. So when we find the positive square root of these such numbers, we are hoping that they are going to give us some two answers, like square root of A minus square root of B. What did I use minus over there? Look, if the question were 3 plus 3 root 5, and I say find the positive square root of this, then you will do this for me. You bring the square root sign, the major square root sign, and then you now put square root of A plus square root of B. This square root of this positive in the middle is because this guy is positive here. If this guy is negative here, because there's negative between these two guys. That is why I will use the negative sign. Yeah, so that's first step. First step is equating it because you're finding the square root of this compound thing, 3 minus 3 root 5. We need to put everything under one umbrella of the square root. And then we equate it to, we are assuming when we find the square root of D, they are going to give us some square root of A minus square root of B. If it is plus, then you use the plus as well. Now, we now have an equation. Now you need to solve it. Now we need to solve for the equations and make sure that we find A and B at the end of the day. So what do we do? First, you want to eliminate this square root. So what we do is that we square both sides. What you do for this side, you do the same thing for the other side as well. That's how we solve our mathematics. So in the previous video, we said that we talk about this elimination of the set by when something is squared. When something is squared and everything is under one umbrella, we say that this can eliminate these square roots because of that reason. Everything is under one umbrella. So if you find the square root of that, these two can easily eliminate this. At the end of the day, this side give us 3 minus 3 root 5. What would the other side give us? So if you do this one, these two cannot eliminate this or this. We said that in the previous video, the back end information video, where you get the concept why, when and how to do the elimination when you are squaring everything in a bracket. Some people do the mistake and just use these two to simplify it. Like it doesn't happen. But this one is possible because everything in the parentheses is under one umbrella and the square root is the square is on all everything. So you can easily do that. But here everything is not under one umbrella, so this square root cannot eliminate that. So you need to do your expansion. Your expansion, basically, this one is trying to give you root a minus root b. Remember, if you have 2 squared, it's the same as 2 times 2. 2 cubed is just 2 times 2 times 2. So if you have root a minus b all squared, you just root a minus b multiply another root a minus b minus root b. Yes. So then you do expansion. So we did expansion in the multiplication video. Kindly look through that, how we did the expansion. And then when you do the expansion, you will finally have something a plus b minus 2 square root of a ab. Yeah, this is what we will get at the end of the day. This is what we will get at the end of the day. Now, here is where we have to play a critical role. You see that from this to, you see that in this term, on this equality of set, this is where equality of set comes in. Meaning that if whatever we have on the right hand side is equal to whatever is on the left hand side, then something should come in. It means that these guys are like terms here, a plus b, they don't have square roots, right? So all of them put together. And if you look at this side, these guys all have square roots coming together, 2 roots a plus b. They also form another one compound. So then if you look at this side, which guys don't have square roots? It's only 3 that doesn't have square roots, right? And the negative is here and the negative is here. Fine. Then 3 roots 5, and this will form the other compound. You see that 3 is the one that doesn't have square roots. And then a plus b together, they don't have square roots. So we put them together. And then on the other side, 3 root 5 is having a square root, right? If you go to the other side, 2 root ab is also having a square root. And how do we solve it? It means that we have to now compare, because the equality of sets, right? If those that are not having square roots, we can equate it to those that have square roots, right? Those that don't have square roots can be compared to those that don't have square roots on the other side. Those that have square roots can be compared to those that have square roots on the other side. So comparison, that's where equality of sets comes in. So the first one, we are saying a plus b should be equal to 3 for equality of sets. And then 2 square root of ab should be equal to 3 root 5. Yes, so we simply just equated both sides. Now let's try to, so we kind of compare or equate items that are common. So those that don't have square roots are equated to those that don't have square roots on the other side. Those that have square roots are compared to those that are having square roots on the other side. That's the simplest way of doing that. Then we need to continue and solve for our a and b. So we are trying to find our a and b. So we know a plus b is equal to this, and from here we have this. First, it's comfortable to remove the square root anytime, right? So we are going to work on this guy. We are going to work on this size because we want to eliminate the square root. If we eliminate the square root every time, what do we have to do? So we might want to find, let's try to find what should we do? I think we can just eliminate, we can just make root ab the subject, or maybe equate both sides. So square root of ab, so you divide through by that, so you have 3 over 2 root 5. When you do the division, you are going to have this. So what we have from there is root ab is equal to 3 over 2 square root of 5. We need to eliminate the square root. So what we have to do is that we have to equate both sides again. So square those sides, and then here you square both sides. At the end of the day, this one will just give us ab, and what would that one, the other side will give us 9 over 4 times 5, because this is multiplication. So these two this to be able to this is the same as, let me do it like this, 3 over 2 all squared times root 5 all squared. So when you do that, you are going to have this. If you can even put it in your calculator, then you finally have something like this. So our AB is equal to 45 over 4. But from the previous thing, right, from this guy, from A plus B, we know that A plus B is equal to 3. So if A plus B is equal to 3, it means that A will be equal to 3 minus B. Are you fine? So we are going to replace that A into this. So in replacing A, what we have, we know that A is 3 minus B multiplying B is equal to 45 over 4. So let's solve for B. So now what do I have? I will now have 3B minus B squared is equal to 45 over 4. So at the end of the day, we have B squared minus 3B plus 45 over 4 equals to 0. From here, we have to do factorization to factorize and get our B. Once you get B, you can easily get an A. You can easily get A, right? Yeah. So this question, I just picked it from my head. So it's not giving us something simple. So I'm going to bring a particular example that will make us have something simple to that we can easily factorize at the end of the day. This is how to show you how to do that. Then now let's solve practical example from that I'm picking from Akiola again. Yes. So yeah, let's see example that we have from there. So the example we have here is we have to find the positive square root of 49 minus 12 square root of 5. So this is the question that we have to find the positive square root of this. So find a positive square root, meaning that finding the positive square root, you need first introduce a big square root sign under on everything, and then equate it to square root of A plus square root of B, which might be some numbers that we are finding. Should it be plus? No. Yes, I know you might be thinking that yes, it shouldn't be plus. Why? Because the middle sign here is negative, so we need to keep negative here. Yeah, we could work with the positive, but at the end of the day, we came back to the thing. But it's best to just, if it's minus here, let's keep minus here and be safe. So now, what do? We square both sides. So we announce what we have the equation. We solve both sides. This one is able to eliminate this based on the reason that we discussed in the previous video. Then 45 minus 12 square root of 5 will be equal to, when you do this, we say that this one, the root cannot, the power 2 cannot eliminate the square roots. So you have to first eliminate yourself, repeat, do expansion yourself. At the end of the day, you have 45 minus 12 root 5 is equal to, so when you square this, when you expand this, you are going to have A plus B minus 2 square root of AB. That's what we have at the end of the day. So now we need to compare. So these ones are not having square roots. And you see on the other side, this guy too is not having any square roots. At the end of the day, we can compare them. So A plus B is equal to 49. Now, this one has a square root, right? Those that have square roots, we compare them to those that have square roots on this side. So we have this. So at the end of the day, we have 2 root AB. 2 root AB is equal to 12 square root of 5. So let me make root, I'll continue with this one and make root AB the subject, meaning I have to divide both sides by 2. At the end of the day, I'll have 6 square root of 5. Now I need to eliminate the square root again. So I will eliminate this square root by finding square of both sides. So if you find the square of both sides, this one, we know that this one will eliminate this. Then you have AB. But then if you have to finding the square root of this side, you can put it in your calculator. 6 root 5 all square, everything squared. You are going to have let me see, 36 times 5. Let me use my calculator. Yes, so you have to use your calculator, right? 36 times 5. let me be sure. Let me be sure of what I'm having in my mind is the same as what, so 6 square root of 5. Yes, so 6 square root of 5. I'm coming. I hope you are also working on it at your end. 6 square root of 5. Yes, I have 180. I hope you also had 180 at your end. I had 180. Yes. Let me adjust this. Yeah. So we have 180. That's what we have finally for this guy. But we also know that a plus b is 49. We know that a plus b is 49. This one means that a is equal to 49 minus b. I just send this b to the other side. So it become negative 49 minus b. Now in this equation, ab is equal to 180. I want to just have one variable inside there. So I'll just replace when I find a in this, I'll just replace with 49 minus b. So 49 minus b is replacing our a. B is equal to 180. So with this 180, we now expand. We have 49 minus 49b minus b squared is equal to 180. So I like writing everything in a squared plus bc plus bs minus c form. So rearranging, well, I'll just have b squared minus 49b plus 180 equals to 0. We need to now factorize. This and then make sure that we have our so this one needs factorization. And so yeah, let's try to factorize. I think let's use a calculator, right? So what I'm having here, when you factorize, you finally have b minus 4 multiplying b minus 45. We'll do a topic, right? As a topic that's handle how to do factorization quickly. So we'll do that. That's why I'm taking my time with you guys, so that I'm hoping that, but if you know factorization already, you know where this thing comes from. But if you don't know, don't worry. We'll have um we'll have a session on that. And that will be under one topic like functions. So functions, will more on functions here. We'll do the factorization or almighty formula and all the methods there. Yeah, that's what we'll do there. But now let's use it here like this. So at the end of the day, we know that b will be so b minus 4 equals 0, or b minus 45 is equal to 0. So b is equal to 4, or b is equal to 45. So this is what we have for b. So when b is equal to, so we know the value of b, right? We know that a is equal to 49 minus b. Then we got b value. So if b is equal to 4, then a will be what? 49 minus b. 49 minus 4, which is the b. So our a is what? 45. Then if it is 45, then a will simply just be 4. Yes. So now we need to decide. We need to now decide which one should we write first. By that I mean when we are done getting the answer, we show that a is 45. So when b is equal to 4, a equals 45. When b is equal to 45, a is equal to 4. But then we say we wanted to write everything in this form in such a way that we have square root of a minus square root of b. But let's look at this. We are looking for positive square root, right? So if you do this subtraction, square root of a minus square root of b, it should give us a positive answer. Is that not the case? It should give us a positive answer. But so we have two values. B can be 4 or 45. A can be 4 or 45. But then which pair can we going to choose? So if B is 4, right, and A is 45, when you do the subtraction, what do you think? The answer will be positive, right? But if you make B 45 and make A 4, when you do the subtraction, the answer will be negative. But we are looking for positive square root. So we are looking for the arrangement in such a way that the final answer should be positive, because you are looking for positive square root number. So A should be the bigger number. So you need to make sure A should be bigger than B, so that when we do the subtraction, we finally get a positive answer. So at the end of the day, A is equal to 45 and B is equal to 4. This is the answer that we need to supply as our final answer. So yes, basically, what's our final answer? What's our final answer? What's our final answer? Our final answer is, so positive square root of 49. So square root of 49 minus 12 with 5. The positive square root of that is equal to square root of 45, which is A, minus square root of 4 is what? 2. Say that. So yes, this is what we have at the end of the day. This is our final answer for what we need to actually have. Yeah. So yeah, you can simplify the square root of 5 as well. You can try to simplify the square root of 45 as well. If you simplify the square root of the 45, so I think that's 9 times 5, right? So that's 3 root 5 minus 2. Put this in your calculator and it will just simplify it for you. So our final answer is just this, the simplified form. Yeah. So this is how to find a positive square root of numbers. Then we will help with in the next video we'll try to look at, this is what we did now is positive square root, right? In the next one we'll try to find solve radical functions where there are variables x that we need to find. That's what will be happening in the next video. So take your time and go over the positive, go over the videos again if you don't understand at a point, and put your concern in the comment section, like and subscribe so that we can continue exploring our video. If you don't watch the previous video, you might get confused at some of the things that we mentioned over here. So kindly follow up so that you can grasp your concept, so that you can move on in this one. Thank you very much and see you in the next video.